Once again, we're going to use the used car data from example 1. We're going to generate 5 random numbers between 1 and 24. Remember, there were 24 cars here. So I'm going to go alpha randint 1, comma 24. And I got 6. Now if I just press equals again, I get my next random number. So that's 19. And then I'll press equals again, I got 7. Now there's a chance we'll get a repeat, and if we do, we just recalculate. And the next one is 22. And then finally, I got 10. So I didn't get a repeat in my 5, but if I did, I would just recalculate. So, which cars do we want here? So we want number 6. So 1, 2, 3, 4, 5, 6. That's F. F is the 6th letter of the alphabet. While I'm there, G is the 7th. So I've got this one and I've got this one done. And then 8, 9, 10. So J is the 10th letter of the alphabet. 11, 12, 13, 14, 15, 16, 17, 18, 19 is my next one. And then I've got 20, 21, 22 would be this one. So the car prices that I have here are, let's put them in order to start with. So the 5,900 was the smallest. Then the 6,400. Then 8,950. 9,900. And my biggest one was 10,200. Calculate the mean, median, and range for the sample. So, well, the median, since I put them in order, is going to be 8,950. And we need to calculate the mean. So, I'm going to use a fraction template and put in my values. 5900, add 6,400, add 8,950, add 9,900, add 10,200, divide that by 5, 8,270, and the range is going to be 10,200, take away 5,900, and that's 4,300. Repeat the process to get statistics for another sample of 5 cars. I'm just going to pause and do that, and you'll see the results when I've done it. So we can see what I got here. Note, and you can see it both in the table and here, that car number 10 ended up being in both samples. Compare our results with the population parameters. The population parameters are stated here. Well, neither of the ranges are anywhere near. That's actually not surprising. To get that range, we would need to have the most expensive and the least expensive car in our sample. So it's not surprising that the range doesn't match. So if we look at the mean, this one is a bit greater and this one is a bit less. The larger the sample we draw, the more representative it ought to become. And in fact, if we pool these, and since they were both samples of size 5, I could just simply do 8270, add 6990, and divide that result by 2. And that is closer to the population parameter of 7750. The medians are, well, this one's quite a bit bigger than the population, but this one is quite close. But the important thing to note here is the variation in samples. Now, these were genuinely taken randomly, generating random numbers on the calculator. You saw me do the first set, and I can guarantee you I did the second set randomly as well. In examples 1 and 2, I really cherry-picked the data. I cherry-picked Opie's to be far too small, Josie's to be far too large, and Jasper's to be pretty good in terms of the mean. And I made sure that the highest price and lowest price were in there, so it was spot on in terms of the range. So it just shows you the variation that you can get in random samples.